Assalamu alaikum. I am Dr. Saeed Ali Mardan Azmi. Welcome to my YouTube channel. In today's lecture, we are going to discuss exercise 15.2, question number 20 from Thomas Calculus 12th edition book. The statement of problem is sketch the region of integration and evaluate the integral. In this integral, y is our inner variable and limits of y are 0 to sine of x. X is our outer variable and limits of x are 0 to pi. In multivariable calculus or in double integrals, we will always solve inner integral first, and then on the result of inner integral, we will apply the outer integral. For this purpose, I have isolated the inner integral inside the bracket with red color so that you will be focused on this particular portion. Now we will integrate y for the limit 0 to sine of x. Integration of y with the help of our formula is y squared over 2. In the next step, we will apply limit with the help of fundamental theorem of calculus. Upper limit minus lower limit. So for upper limit, we have replaced y with sine of x, and for lower limit, we have replaced y with 0. So we are left with 1 by 2 limit from 0 to pi sine square of x. In order to integrate sine square of x with respect to x, we will replace it with a trigonometric identity 1 minus cos 2x over 2. Now the 2 in the denominator is constant. It will multiply with the 1 by 2 outside. So we have 1 by 4. Limit from 0 to pi 1 minus cos 2x. In the next step, we will apply the integral on each term separately. So we have 1 by 4 bracket start limit from 0 to pi 1 dx minus limit from 0 to pi cos of 2x dx. Please note that the integration of first integral is straightforward. We will get x, but in the second integral, our trigonometric function is cos of 2x with angle 2x. Whenever your angle is different from the variable with which you are going to integrate the given function, you will create the derivative of the angle first, because if you don't have derivative of the angle as a multiplier, you will not integrate this function. So in order to create the derivative of the angle, we will multiply this trigonometric function with 2, and then in order to balance it, we will divide with 2 outside of the integral. So we have, in the first integral, we have the integration x, limit from 0 to pi, and for the second integral, we have minus 1 by 2. This minus 1 by 2 with red color is here for the balancing purpose of this 2, which I have used here as the derivative of the angle. In the next step, we will integrate cos of 2x multiplied by 2 dx with respect to x, and I get sine of 2x. And for the first part, I have applied the limits, upper limit minus lower limit with the help of fundamental theorem of calculus. So here we have 1 by 4 pi minus 0 minus 1 by 2 sine of 2x limit from 0 to pi. Then pi minus 0 is pi, 1 minus 1 by 2 as it is. I have applied limit in sine of 2x. I have replaced x with pi in the first term and x with 0 in the second term. Now sine 2 pi is 0 and sine of 0 is also 0. So this whole term inside the bracket is 0. So we are left with 1 by 4 pi minus 1 by 2, 0 minus 0. And our answer is pi by 4. This concludes the first part. In the second part, we will learn how to sketch the region of integration. For the region of integration, we need 4 boundaries. And these boundaries will come from the values of our inner and outer variable, which are available in our limits. The limits of y are 0 and limits of y are sine of x. So we will take y equal to 0 and y equal to sine of x. And then similarly, we will take x equal to 0 and x equal to pi. And these equations will give us boundaries for our region. Now x equal to 0 is equation for y-axis. X equal to pi is equation of a vertical line, which passes to the point where the value of x is pi along x-axis. Y equal to 0 equation of x-axis. And y is equal to sine of x is a sinusoidal graph, which look like this. Please note that in our sine function, the graph of sine function starts from 0. It takes a maximum amplitude equal to 1 and the minimum value is minus 1. The graph of sine function is a sinusoidal wave. Now for our region, we will plot x-axis and y-axis first. And then I have marked x equal to pi and y equal to 1, because in our graph of sine function, it will start from 0 and at pi for the limits of x, and this line is a vertical line for x equal to pi. Now, I'm going to indicate the equation for each boundary: y equal to 0, y equal to x, x equal to pi, and and y is equal to sine of x. Please note that the region of integration is the boundary region which contains or which involves all these four boundaries, and this region is highlighted as green color. Thank you for watching this video. Please like and subscribe to my channel if this video is helpful for you. Thank you for watching.